Okay, what are we looking at first?
Okay.
Yeah, which page?
The long one.
Yeah, come on, get out your book. Tell me which page. Yeah. 42. 42.
34.
Yeah, we can get that in a sec. 42, 8, is it?
Yes, 8.
Yeah, okay, let's have a look. Will I do 8A?
Yeah.
Yeah. Okay, let's have a look. Page 42, question 8A. So you're told, for the geometric series below, find the first term A and the common ratio or if the ninth term, so U9, is minus 6561, and the sum of the first two terms is 2. So here you have A or 8 equals minus 6561, and then the sum of the first two terms, that's A plus A or, that's equal to 2. So what I'll do next, I think, is I'll just change this into A times 1 plus or equal to 2. And then I have A equal to 2 over 1 plus or. And I can sub that in there. So I'll just replace the A now with 2 over 1 plus or 8 equals minus 6561. And then I'll divide by the 2. Minus 6561 over 2. Now, not that it matters too much, but it's a little bit easier if I just write the minus the bottom instead of the top, which I'm allowed to do. Okay? Now, is it 6561? Yeah. I'm sure that 6561 can be simplified into 3 power.
Yeah, 3 to the power of 8.
3 power 8, is it? 3 power 8 over minus 2. Now, if you look at what you have here and what you have here, you realize there's not a huge difference. Probably the R is going to be the 3, but we want to make sure we can match it perfectly. So I'll change this into 3 power 8, 1 minus 3. Okay, so not quite there yet, just one thing left to do. I'll change this into, instead of 3 power 8, minus 3 power 8. And instead of 1 minus 3, 1 plus minus 3. So what I've managed to do is manipulate the right hand side so it perfectly matches the left hand side. And clearly I can see that or has to be minus 3, which I'm sure is the answer at the back, isn't it?
Yeah.
Yeah. Okay, these are hard ones. You should write that down if you didn't get it.
By the way, do you record tutorials?
Yes.
I have a question.
Well, I think you're next. What one did you have?
34.
34.
5A.
5A. Yep, we'll do that one now. Yeah, you got that? Yeah. So 34 now, 5A. So you're told that px plus q power n is equal to minus 64 minus 96x minus 48x squared.
Wait, page what?
34. Yeah?
A.
5a. Yeah? Now, we know if we expand on the left, we get NC0. Yeah? We can do the px first. Yeah, px power 0, q power n. Yeah. Plus NC1, px1, q n minus 1. Plus NC2, px squared, qn minus 2. And that should equal minus 64 minus 96x minus 48x squared. 48x squared.
Why? Why minus 2?
It's the next one after n minus 1 and n.
Yeah, why? Why did we put n minus 1 and n minus 2?
Ah, you know this. When you expand, this guy goes up and the other guy goes down. When you move to the right. So 0 becomes 1 and 1 becomes 2. And then the other fella goes opposite. N, you lose 1 and then you lose 1 again.
Yeah.
So one goes up and the other goes down. That's what's happening. What's NC0?
1.
Yeah. The first number is always 1. And PX0? 1. So what's actually the first one here?
QN.
QN. Now does anybody, if you think about Pascal's triangle, you can probably figure out what NC1 is, the next number. If you look at the triangle, do you notice how the next number in, like is 2, is 3, is 4, is 5. What's the next one here going to be? 6. So on the nth row, what would we expect? N. Yeah. So that makes the next one here n. Plus n p q n minus 1 x plus. Now NC2 is a little bit harder. We'll have to do some work on the side for that one. You'll have to remember the formula for NC2. What's the formula? What's on the top? Do you remember?
N factorial
Yeah.
divided by r factorial n in brackets n minus
Yeah.
r.
So in this case it'd be n factorial, 2 factorial,
Minus 2, yeah.
n minus 2. So n factorial is n times
And what?
n minus 1,
Oh, yeah, and the
Minus 1.
n minus 2, and so on.
finishing at 1. 2 factorial is 2. And n minus 2 factorial is n minus 2, n minus 3 to 1. Yeah?
So we can divide.
Yeah.
Cancel it.
So you're left with n squared minus n over 2. So that's NC2 formula. So in a moment, if you want to write that down, we'll go back to the main question. Who am I missing?
Hmm?
There's only 12 in this group?
Sorry, minus 2.
Yeah, there's only 12 in this group? Okay. How many is in the other group? Is it only 22? Okay. Okay. Right, you got that? Can we go back to the main part?
Yeah.
Yeah? Okay. So, n squared minus n over 2. N squared minus n over 2. Isn't that what I said?
Yeah.
Yeah. P squared q n minus 2 x squared equals the same thing. We'll just write the same. Now what we can do is start comparing. So, Who can spot what Qn should equal? If you look at the left and then look at the right, here's the right here. Very good, it's minus 64. The first one should equal the first one. And then n, p, q, n minus 1, what should that equal? Minus 96, isn't it? We won't bother with the x, we'll just look at the coefficient. And then n squared minus n over 2,
Minus
p
14.
squared, yeah, qn minus 2 would equal minus 48. Okay? So I'll just clean this up a little bit. Qn equals minus 64. I'll change this into n, p, qn over
1. A, Q.
q. Got there. Good. And then this one, n squared minus n. I'll bring the 2 up to the right to make it 96. Maybe that'll be a little bit easier. And this will be p squared qn over
Q.
q squared equals minus 96. Yeah. Now, what would be a nice substitution here?
QN.
Qn, isn't it? Because Qn can go into there and into there.
Yeah.
So then you get np minus 64 over q equals minus 96. And then here you can get n squared minus n, p squared over q squared, and then once again minus 64 equals minus
96.
minus 96 then. Yeah? Now, I think I can clean these up a little bit. Like 96 over 64 is 3 over 2, isn't it? I think so. So, what I can do is I can say this is p over q. Yeah, is 3 over 2?
Yes.
3 over 2n.
Oh.
And then here I can say n squared minus n times p over q squared again equals 3 over 2. Now what can I substitute?
PQ.
Yeah, I can put this in.
Mhm.
So now I get
Oh.
n squared minus n over 3 over 2n squared equals 3 over 2. Okay? This will be n squared minus n. That will be 9, won't it?
Yeah.
So I'll bring the 9 down. And that will be
Oh.
4n squared. I'll bring the 4n squared up. 2 goes into 4 twice. 3 goes into 9 twice. Bringing the 3 up to the left. 3n squared minus 3n equals,
N squared.
I think 2 still there.
2 and
2n squared. So that's n squared minus 3n equals 0.
quadratic.
Well, it's simple quadratic.
N minus 3.
Yeah? So what's the n?
3.
N is 3. Now, we can work backwards now. If I put, where's the easiest one? There was one earlier, wasn't there? The qn equals 64. If I go backwards, now I have q cubed equals minus 64. So that means, going backwards, q, what was it? Minus 4. Yeah. And then if I put it into this, that's n is 3, q is minus 4. I have p over minus 4 equals 3 over 2n, which is 6. So does that mean p equals minus 2?
Yeah.
Okay, that was the hardest question in the book maybe so far, I think, right?
How many marks will we get for?
Oh, this would be way too difficult for the exam.
Ah,
Way too difficult.
Then this would be like coursework.
If you
no,
put
that's-
that-
it's still
if it-
easy
if
for
it-
coursework, yeah.
No, I'd say it'd be
A bit harder.
no, maybe a little bit harder. I can tell you that your coursework won't be harder than this.
What does coursework mean, like, for maths? Do we, like, explain words
NCUK
and
just want you to, they give you like a worksheet of like 4 tasks on it, you know, and each task might have multiple parts. So it's just like a homework sheet really, except maybe for some of the tasks they might want you to use Excel or make a graph in Excel or something like this, you know. Yeah?
Page 44.
44.
Oh,
Yeah, in a sec, yeah. Which one?
What is
Yeah, which question would you like me to do?
3 and 4.
Okay. We'll just give people a minute to write this down.
no,
You don't need to, it's going to be on YouTube.
I'm lazy to open it.
No.
Wow.
So you don't feel interested?
Disappointed.
Well, that's one view I lost. This video's going to have 0 views now, you know that, don't you? Alright, thanks. Right, we'll look at page 44 now. Which one? Will I do 3A?
Begin.
3A? Yeah? Okay. So you have Tn equals minus 5n squared plus 8n plus 5 over minus 4n squared plus 2n.
Which one is it?
3a
3A.
on 44. Are you on page 44? Yes. Okay, so what I'll do first, I'll simplify the formula. I'll divide everything by
N squared.
n squared. So 5n squared divided by n squared, 5. 8n divided by n squared, 8 over n. 5 divided by n squared, 5 over n squared. 4n squared divided by n squared, minus 4. And then 2n divided by n squared, 2 over n. Then I'll make n go to infinity. So I get t infinity equals minus 5 is 5. 8 over infinity, 0, 0, minus 4, and then 2 over infinity, 0. So the answer will be 5 over 4 then. Okay, write that one down. And then we'll do 4a.
I think we'll even need your tutorials because of your videos with all examples because it's like perfect direct progression between like examples of you give and the homework we receive.
You can rewatch the lesson and it matches up. Yeah? Which one? Well, I'm going to do 4a next, but then what do you want?
General formula.
The last step?
Yeah.
This one here?
Yeah.
These guys here, here, and here all become 0 because they are like a number over infinity. That's 0. So 8 over infinity is 0, 5 over infinity is 0, and 2 over infinity is 0.
So n like considered as infinity.
Yeah, you make n as if it's infinity. Yeah. Yeah.
Okay.
So what's the meaning of computer?
Calculate.
Calculate.
Yeah. Which one?
36, page 36, exercise 4 and
For,
Mister?
yes, 1 sec. So I'll do 36 in a second. You want 4a as well, isn't it? Yeah? Question or no? I'm going to do 4a next for you, yes?
Yes.
Yeah, okay. 4a,
which page?
the same page. And then we'll go to 36.
No, 4 M.
4m. Ah, yes, okay. 4m? Well, it's all the same, isn't it? 0.9999 repeating. Okay? So before I start, I want you just tell me what you think. If you were to fill in the box here, and here's the number 1. So in the box, would you say less than or equal to, equal, more than or equal to? So you have 1, 2, 3, 4, 5 choices. Which one would you put in here?
Greater than or equal.
You would put in this one, yeah?
Yeah.
Anyone else?
Just less.
You'd put in just less, okay?
Yeah.
So we're kind of thinking it's one of these guys. Yeah, let's have a look. So, right. So this is equal to
If it's a progression or just it's
infinite, recursive, recurring decimal. Let's have a look. So you can change this into 0.9 plus 0.09 plus 0.009, etc. and so on. But if you look carefully at this, you'll notice that this is GP with A equal to 0.9, and what would OR equal? Yeah, it could be. What way do you want to say?
0.1.
0.1. 1 over 10.
Yeah.
Yeah.
These are getting 10 times smaller each time. So this is S infinity.
Formula A divided by R min
1 minus R. A divided by 1 minus R. A is, what do we say? 0.9. And R is,
1 minus 0.1.
yeah.
Yeah.
Isn't that right? Yeah.
So
Which is
1.
0.9 over 0.9, which is 1.
Yeah.
So this equals 1. Not less than.
If
Equals.
it's progression or at all.
Infinite progression.
How did you get the 1 over 10?
You can do it on your calculator if you like. You take the second term and you divide it by the first term. This gives you the OR. That's the easiest way to do it.
Okay.
Interesting, isn't it?
So
Isn't it?
There's no friction.
Well, 1 over 1, if you want.
But yeah.
Yeah. Now, what did you say? 34 is
36
36
says 4.
for F.
Yeah.
Okay.
So like, probably we shouldn't like look at, I just forgot how we get V1.
With double.
The second one,
Yeah,
V2.
Yeah, because
Yeah.
like, I put the V1 inside and get
Yeah.
V0, and like in the other way, but we need V2 and all this.
Okay, let's have a look.
Yeah.
Let's have a look. Can I scroll down,
Yes.
guys? So, for F on page, isn't it 4F, Nikita? Yeah, 4F?
Yeah.
Vn equals minus 7 plus 4 over Vn minus 1. Okay? So, what, according to this formula, if I want V2, what's n equal to? 2. If I want V2, make n equal to 2. Let n equal to 2. So you get V2 equals minus 7 plus 4 over V1.
Yeah.
Yeah? But what is V1 in the question?
8.
8. Yeah. Minus 7 plus 4 over 8. So what do we get for V2? That would be
Minus
minus
15 over
6.5, isn't it?
Okay.
So you can use your calculator, and the first term is 8, wasn't it? And the next one is minus 6.5. And then the next one you would have to put minus 6.5 in here. So we can repeat it like this. Minus 7.62 roughly, yeah, and then minus 7.52 roughly, and so on, etc. So when I look at this sequence, it seems to me to be convergent. Maybe convergent to possibly minus 7 or minus 8, or maybe even minus 7.5, I don't know. I don't think I asked you for the limit.
My problem was I was putting V1 instead
In on the left.
Yeah.
You should have put in on the right. Yeah. Yeah.
So the answer of this, like we did.
Yeah, exactly. Yeah. Yeah. But no -1.
Without -1?
Mm.
So usually, how many decimal places you need to count?
Exam asks for minimum 3 SF for the answer.
Okay.
But more is fine. It's just 3 is the minimum. Unless they specifically say something in the question. So I always tell the students I recommend to go for 4 SF for calculations as a minimum. But if possible, using fractions might be better.
Let's choose.
Yeah, but
Yeah.
questions like this
Yeah.
for finding convergent or divergent, we need to use decimal.
It's better for this one, yeah. It's clearer. Yeah.
Can I just see how, because I got to 6.428.
Oh, this is just rounding off on the calculator. So this could be right, because the answer you can see here, it's not exactly 7.62. You see here, it's 76154. What did you get?
7.538.
That's a little different. Oh, that's the next one, 7.538.
38.
Yeah, it's because of if you know how many decimal points you use. You know, so what's the next one you got? 7.
0.4.
Yeah, this looks okay. Maybe, how did you type it in on the calculator? Can you show me?
Yes, it's better.
Okay, you got that? What's next?
Let's do here, here Vn -1. So we have to use 8 and
There's
Vn
a minus
-1.
No -1, because the meaning of the -1 is not -1 like how you have the -1. It just means the last term. The meaning of Vn -1 is not. It's not this. It's not Vn -1. It's like this. Vn -1. It just means V, the last guy. Yeah.
And then the answer I got just
Exactly. Yeah. 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 No -1.
Why?
I explained it. Haza? Did you understand my meaning with the
Yeah,
-1?
you mean
So
that-
yeah, you can explain it to her in English. Right, guys. Wait, Nikita, what did you say? Which one was it? Or no, you asked me. Yeah, which one? 46 number 13. Yeah. Okay.
But it's like Vn -1. So like the
Did you try it and didn't get an answer, or?
I didn't get the question because they say how many people click the first thing, but everybody clicked the first thing. So she needs to.
No. 70% of people who clicked all links clicked the first link, right? Are you? Yeah. The question is saying that when you have a Google search result, so many people will click the first link, obviously, and then 70% of that number of people click the second link.
But they say how many people clicked the first link.
Correct, yeah.
So shouldn't it be the whole number, like 1,000?
No, because that 1,000
Is
was.
how many people clicked the first link?
No, I
How many
didn't say
people
that.
are looking for search results?
Yeah, but the 1,000 people searched, and you know, as I say there, and clicked links. I didn't say and they clicked the first link.
So the 1,000 is some.
Yes, all the clicks for all the different pages. It wouldn't be a difficult question if I asked you how many clicked the first link and I said it in the question. That'd be a little bit too easy, I think. Right, let's have a look at it. Page 46, number 13. Page 46, number 13. Guys, come on. Guys, come on. Page 46, number 13. The number of people who click the second link in Google is 0.7 times the number of people who click the first link. For example, if 100 people click the first link, then 70 people will click the second link. The number of clicks for the third link is 70% again. So that would be what? If 100 click the first and 70 click the second, then how many is clicking the third?
80.
No. 49.
Again?
Guys, are you listening? I don't have your full attention. So I tell you that it's 70% reduction next time. So if 100 click the first link,
Mm-hmm.
70% of 100, 70. That's how many click the second link. Then how many click the third link? 70% again. So if it was 70 previously, then the next time is 49. You're taking 70% each time going down the list.
So we
So
took
only
70%
three links or more than
70%.
One sec, huh?
How many links in total? Like
Well, this is the thing. Yeah, we'll get to that in a moment. We can assume it is. I mean, in real life, of course, it's not. But what is it like? You know, you'd have millions of search results, so you can kind of assume it.
So it should be infinity, right?
Yeah,
I know.
yeah,
So it's three.
yeah.
Yeah.
Hang on, you were asking me?
So yeah. So we took the 70%
Yes.
of the 70.
Correct. Yeah. So it keeps going down like this. The list. So, for example, in the first result, number 1, if 70 people click that, then if 100 people click that, then the next one, 70 people click it, and then yes, correct, 49, and it keeps reducing like this down the list. Okay, guys, come on! I can't have you talking while I'm doing the example. Okay, right. So now on to my question. So I don't tell you how many people click the first link. So we'll just call it X. We don't know how many click the first link. Okay? But we do know the rule. So how many click the second link?
X 0.7x.
0.7x. Yeah? And then how many people click the third link? 0.7 squared x. And so on. All the way down. I tell you, etc. If you add up the total number of clicks on every page on this result, you'll get, I think I said 1,000, didn't I? So that's me saying S infinity is 1,000. Yeah? So A over 1 minus or, what's or?
0.7.
7. That should equal 1,000. So then you can solve, and x is 300. So what happened was 300 people clicked the first link. Then, what's that, 210? Clicked the second link. Then 147 clicked the third link, etc., etc., etc. And in total there was 1,000 clicks. Okay, I don't know if you got that one. You probably didn't, so you should write it down.
But so
Mhm.
the like when it goes down, it's
Yeah.
like getting decimal places.
I know.
But it's not logic for you.
It's only an approximation. I also said there's infinite web pages, which is obviously not true.
Oh, okay.
So this kind of question could come out from the exam.
I think this is the right level of difficulty for the exam. I mean, all I did was this.
Yeah, but I don't like practical problems.
Nobody
Too
does.
much words.
Nobody does.
Can we take a look at series?
Yeah, which page?
Wait.
38.
Yeah.
I have a question.
Yep.
Why minus 1?
Why, where?
We minus by 1.
I mean 1 minus.
Yeah.
I'm using the formula.
Yes.
S infinity equals A over 1 minus or. That's right. You know this formula? Yeah. Which page?
38.
38. What's that one?
That's question. First exercise.
Yeah.
Question why?
1y, is it?
Yeah.
Okay. Can I scroll down? Yes? Yes? Okay. Page 38, 1y. Minus the sum from I is 5 to 9, 2 over I. That will equal minus, bracket, first we start with 5.
Yes.
2 over 5, plus 2 over 6, plus 2 over 7, plus 2 over 8, plus 2 over 9. You put that in on the calculator and you get minus 1.4913. And that is that.
Can you remind me how we reverse this? This.
How we do what?
How we get like 2 over 5 and
Ah,
over
the I.
yeah.
The I gets replaced by 5. And then it gets replaced by 6, then by 7, then by 8,
Until
then
9.
by until 9.
This helps.
So can you write in fraction?
Huh?
Can you write in fraction?
Yeah.
Can you do Z as well?
Yeah, Z was
Yeah,
an
Z-
interesting
Z-
one. Z was an interesting one. Sum equals m from 1 to 8, the number 2. So you replace by 1, but there's nothing to replace. So what is the value of 2 when m is 1? Well, it's still 2. What is the value when m is 2? It's still 2. M3, M4, M5, M6, M7, M8.
65.
16.
8
Yeah. It's a constant 2. Yeah.
For example,
Mm-hmm.
In D, we just put 4 in and then put 5 in until
Yep.
8, yeah?
Yes.
And multiply
Yes.
it each time by
Yes,
4, yeah?
correct, yep.
Alright.
do we have some time? Probably we could do some practice problems.
Which one, yeah?
Practical.
A practical one? We could probably get one done, yeah. Which one on practical? Guys, on the practical lesson, which one? We'll do one more of those.
Which one?
15.
We did 15 in class.
15 yesterday.
So.
The uranium.
Is there any fast places
The physics
can
one.
like put all the
Calculator.
Yeah,
Which one?
the 14.
14? Yeah? 14, yeah. Page 46, 14. Okay. So, in a reactor, a neutron is fired at some uranium. After the neutron hits the uranium will split into 2 atoms and 3 more neutrons are freed. In addition, some energy E is released in time t. The process repeats. So, first we have 1 free neutron, then 3, then 9. This will cause E, 3E, 9E energy release. And it will take 3 units of time. How long until we get this much energy? So what's happening here is you have a reaction and it produces E energy. Then the next reaction produces 3E. And then the next will produce 9E. And then this continues until, in total, you will get, what did I say? 29524 E.
We almost have everything like S, infinity.
Yes. No, not no, wouldn't be infinity necessary. It wouldn't be infinity because the or here is what?
Just S, just S.
It's just an S, yeah.
Yeah.
But before I start, I'll divide everything by E. So I get 1 plus 3 plus 9. We don't know how many terms, but it should total 29524. This is, as you said, Sn equals 29524. Do you remember the formula for Sn?
N divided by 2.
Yeah, n over 2. 2a, what's a?
A is 1.
Yeah. Plus n minus 1. D, what's D? Oh, sorry. No. That's AP. GP.
My fault.
A. 1 minus,
Minus three
well, or power
and
n over 1 minus or, yeah, minus 2. Now what I can do is clean this up a little bit. 1 minus 3n equals 29524 times minus 2. And then I can bring that to the other side. 1 plus... Oh, we're not finished.
Okay.
Yeah, but
you're
you're...
finished, yeah. You got everything and now
No,
you can go.
take your stuff back out. We're not finished. Yeah, okay. 1 plus 2 times 29524 equals 3 power n. Yeah?
What is happening?
I took this to the left and this to the right.
Okay.
Yeah.
What do I get on the left?
59048.
59048, is it?
9.
9.
Yeah, after plus 1, 9.
59049
Yeah.
equals 3 power n. This is 3 power 10, isn't it?
Yes, it is 10.
Yes. And it's 10. Wow.
N is 10. Well, I remember from the other group. We did that with this one too. So n is 10. Oh, so that means it takes 10 units of time. The 10 processes, 10 steps in the sequence. Yeah?
Let's do another one.
Well,
No time.
let's have a look, see at the time. 2 minutes.
That's enough.
Let's take easy one. 16? Yeah, 16.
Yeah.
We did 16.
Uh,
You gotta ask me questions we didn't do.
15 though.
Now, is this your last class? Or you have the AP or something?
No, it's last.
Yeah, so off you go. 8. Super quick. I'm going to do it in 30 seconds. If you blink, you'll miss it, okay? Right. So, how much sand, how many grains are on the first square of the chessboard? Guys, if you know, answer number 8 at the same page.
10.
No, come on. You're only delaying us. Because I'm going to wait. No, stop. Everybody wants to go, so if I have to stop. No, it's finished when I say it's finished. We're just wasting time. Can we continue?
1.
Yeah. So how many grains are on the first square? 1. And then how many are on the second square? 2. And then 4.
Yeah.
I said in the question it doubles each time, right? And then the next square, 8. So what type of problem is this? AP or GP? GP. Okay. So what's the what GP is it? S. How many squares are we adding together?
24.
Say in the question, how many squares are there? It's the third word. Look at the third word after if a chessboard. How many squares?
20.
There is not 82 squares in a chessboard. There's not 32 squares in a chessboard.
24.
Does nobody know how many squares are on a chessboard?
24.
Huh? No.
That
I
is
don't
16,
know.
right? It's
64.
Yes.
I was close.
8 by 8.
Ah.
So this is GP, isn't it? So that's A 1 minus, and what's the OR? What's the OR here? 264 over 1 minus 2. So the answer will be 264 minus 1. Ah, come on. You know what a chessboard looks like.
He's processing.
Yes.
It takes a while.
Damagi.
Right, okay, go.
Wait, I have a question.
Is it about how many squares on the chessboard? Yeah.
Why 2 to the power of 64 not the opposite?
2 or power n. There's 64 terms.
Why 64?
I'm kidding.
Number of squares.